In this video, we will introduce the MV example base model. Use the project overview window to activate the base model study case. An overview diagram of a 20 kV medium voltage network will appear. It is a geographic diagram. The large circles show the primary substations, and the small circles and squares show the distribution substations. Let's colour the diagram to show which distribution substations are fed from which primary substations. Choose the diagram colouring scheme icon. Choose the option 3 Other. Choose to colour the diagram according to topology, and then choose the option Supplied by Substation. Select OK. You should see that the diagram is now coloured in 4 distinct colours. Each of the 4 colours corresponds with one of the primary substations from which that area of network is fed. Now let's take a closer look at one of the primary substations. Double-click on one of the large circles. A detailed substation diagram will appear. The substation diagram is coloured according to the 2 voltage levels present. The green section of network is a 63 kV network, and the red section of network is nominally rated at 20 kV. You can easily jump between network diagrams by double-clicking on the arrowheads. The selected feeder is automatically highlighted in the overview diagram. Now let's take a closer look at one of the distribution substations. Zoom in on a distribution substation. Double-click on the distribution substation in the overview diagram to access a detailed diagram of the distribution substation. The distribution substation consists of an MV-LV transformer with connected load, an incoming feeder and an outgoing feeder. Additionally, representations of the switchgear and the busbar are shown in the diagram. In this case, all switchgear is in the closed position. Return to the overview diagram. A number of feeder objects have been predefined in this network. The feeder objects group equipment according to the radial feeder to which they belong. We can colour the network feeders in the diagram to get a better illustration of this. Choose the diagram colouring scheme icon again. This time choose the option Feeders instead of Supplied by Substation. You can see that the diagram colouring mode has changed. Each feeder has been assigned a different colour. Suppose we are concerned that feeders are operating in a ring which should be operating radially. We can activate a colouring alarm feature which will highlight such cases. It's called the feeder radiality check. In this case, issues will be highlighted in a particular shade of red. There are no such issues present in the network with its current configuration. Let's switch the network to deliberately introduce a ring and see what happens to the diagram colouring. Find a distribution substation with a normal open point and close the normal open point. Returning to the overview diagram, you will see that the colouring of the feeders has changed to illustrate the alarm condition. Reopen the normal open point and the alarm condition will disappear. Zoom out to show the whole network once more. We will now illustrate the heat maps feature. Heat maps are particularly useful when trying to evaluate the status of large, complicated networks. It is a graphical feature which will quickly draw the user's attention to any problems in the network. Reconfigure the diagram colouring scheme so that the topology is coloured according to the primary substation from which it is supplied. Now choose the Heat Maps command icon. Choose a high resolution and choose an appropriate background colour. Select Execute. You can see that the regions supplied by each of the primary substations are clearly highlighted with the heat map. The specks of additional colour shown dotted throughout the heat map are due to the presence of remote-controlled switches and distributed generation load. You can switch these colours off to obtain a pure heat map. The heat map can be switched off again by selecting the heat map command icon once more. We will now demonstrate how to add a mapping background to a GPS diagram. Right-click on a distribution substation and choose the option Edit Substation. On the description page, choose the Geographical Coordinates tab. You can see that GPS latitude and longitude coordinates have already been added to the substations in this model. Using these coordinates, PowerFactory can determine the location of the equipment in the network in relation to a background map. Choose the Graphic Layers icon, then choose Configuration and ensure that the layer background is selected. Choose the Geographic Map option. In this case, we will use maps provided by OpenStreetMap. Make sure that the background layer is a visible layer and not an invisible layer. The background map appears, and it is clear here that we are not using a real grid. The grid that we are using is an imaginary grid which doesn't have a real location. In this case, the grid is shown located within a large body of water.